Hey there, welcome back. My name is Chris, and today on C# and Sensors, we're going to look at a Hall effect flow sensor. So here's a pretty typical sensor. This sensor has something in it that rotates, and that rotation turns into pulses, and those pulses can be changed into a flow rate. This style here, you can kind of see in there, it's got basically like a propeller or a turbine that rotates, and then that rotation basically has magnets that pass a sensor here for a Hall effect, and that turns into those pulses. There are other styles that have a paddle wheel that rotates this direction that go past, but they do the same thing. In fact, let's go look at a couple more. Here's an example of a couple of these sensors in use. We've got this one here, which is similar to the one that you see on my bench, which has the turbine style. This one kind of has a paddle wheel style. Internally, they look a little bit different, but they behave the same and give you the same kind of results. So when we have one of these, they pretty much all have 3 wires: power, ground, and signal. So what we do is we hook it up and we give it power, usually in the 5-volt range, though they usually have a pretty wide variety of ranges that they can accept. And then we listen for pulses on this signal line. The pulses that come in on that signal line can come in kind of quickly. And so for this one, we're going to use this hardware. This is the Wilderness Labs Project Lab. The important piece there is we have some inputs on this that it uses hardware counting instead of software counting. It's much, much faster. On this one, I could count up to at least 100,000 samples a second. We don't need anywhere near that range, but even 100 samples per second can, if you're using software, tend to saturate the processor and use up a lot of your processor time. So in this case, we're going to use this. That way we're using a hardware input for that signal. So let's wire this up and then do some code. This hardware has a microbus connector, so we've got ground and power here. And then for signal, I'm just going in on the PWM signal. And that comes to one of these. And most of these sensors I find have this 3-pin connector on it, so we can just connect them together, and now we're wired up. And since we're using the Project Lab, we're going to use the Project Lab template to create the app. We'll call this the Flow Sensor Sample, and that will generate our template application. In this case, the template application has a display controller that does a bunch of displays for the sensors on the Project Lab. I'm just going to completely remove that. We're just going to write this out to the console. All right, we're now down to just a bare bones application. So the first thing we want to do is we want to add a NuGet reference in order to get these flow sensors. You can see we've got the Meadow Foundation Sensors Flow Hall Effect. Long name, but it's descriptive of what it is. So we'll install that. And now over here, we can define our sensor. Now these sensors, different size sensors have different flow calculations. So if we take a look at this one, you can see right here, it says it's a YFB1. So I can define this as a YFB1. And then I'll create one. And then all we have to do is give it the pin we're connected to. In this case, you can see we're on microbus 1, and then this pin, it's hard to see because the pin's in the way, but it's labeled just like this one that says PWM. So this is microbus 1 PWM pin. Now down in our run, we'll simply loop and periodically read what the flow rate is and output that through the console. The read returns a volumetric flow. So now we will output that, and we've got different units. So I'll say gallons per hour. You can see we could do cubic feet per minute, liters per minute, a lot of different things. It's just going to do the calculation on the units for us. And really that's our whole application. We've defined the sensor, we create it, we read data from it, and then we react to that read. So really 4 lines of code in order to use one of these sensors. Let's build and deploy this. This will output all of the data down here in the output window, but I'm going to open up a console and use that simply because it's easier for me to change the font, so it's easier for you to read. This sensor does have a direction on it, so the flow needs to go this direction. So what I can do, if I don't have liquid, I can actually just blow through this for air. The calculations are calibrated for liquid, not air, but I can blow through it, cause that to turn, and at least give us some numbers that are changing. And so now if I just blow through it, and the faster that impeller spins, the larger our flow rate. And that's it. In basically 4 lines of code, we've created a flow meter. That's all I got for you today. Thanks for watching.